Molly's going to explain what she did. First she's going to explain how she did the tree. Molly, go ahead.
So I did each branch for, I did a branch for each outcome, and then the probabilities of each outcome, since there was a total of 11 marbles in the bag, I made them all out of 11. And then for each branch off, for the red group, I did out of 10 for each one, minus 1 red marble since we're not replacing, so there's 10 now instead of 11. Same with blue and green. And then I did a little branch off on the side. Yeah.
So does everyone understand what she's saying? She said if you draw red first, now you only have 10 marbles left, and you have 1 less red. So only 1 out of 10 red. You still have 4 blue, and you still have 5 green. Okay, great. Keep going.
Then I did the same for blue. I took 1 out of blue, made the total 10, and then green, took 1 out of green, made the total 10.
All right, so your blues change, but your red and greens stay the same. They're still doing 5. Okay, great. Yeah.
And then to make it more organized, I always put a branch off on the side, and I put the probability of each one,
Nice.
where I multiply it because,
You're thorough. Very nice.
yeah. So then for A, B, and C, I just kind of wrote down for the green or red. I just added the probabilities of drawing green and red together, and then for blue then red, I just kind of selected it from the side. I just kind of followed the branches. And then,
right, so
yeah.
I just need a comment here. So blue and red, that's 4 11ths times 2 tenths. And in case people aren't sure how to do that, 4 11ths times 2 tenths. You multiply the numerators, you multiply the denominators. If you're not sure, student your calculator and you get a decimal, that's fine too. I'm okay with that. Okay.
And then for C, I went to the green branch, and then I chose what the probability of pulling a blue was. Afterwards.
Right. She went to the green branch, and then she found the probability of getting a blue.
Which got smushed.
That can't be right.
Wait, oh.
Probability of
Oh, I miswrote it. I have it right on my paper, but I miswrote it up there.
Blue given green given blue.
It's 4.
Yeah.
I miswrote it.
All right. Yes.
I wrote it right on the tree.
Yes.
Or, yeah, no, I did. Yeah, I did.
Oh, you're right. We did. So it's right here. Go to blue and then probably getting a green. My bad. Yes. I went to the wrong place. Yes. So you said it wrong. So here's the deal. If I'm given, so remember this line straight up and down? That means given. If you're given that blue was first, what's the probability if you drew a blue marble first? 100%. So 100%, you know you are standing right there. If I'm standing right there, what's probably I draw a green one? 5 out of 10. So, does that make sense for folks? So just don't forget that. Or make a note on it if you need to. Okay. Great. I think next, let's do this one next. Weights and hamsters.
It's on the first page.
It's on the first page. There you go. Empirical rule.
Oh, that's right.
All right, empirical rule. Think about what the empirical rule is. Try to work that out. Use your chapter, your exam notes if you need to. Empirical rule. Oh yeah, it does say bell-shaped normal distribution. That's true.
Oh, I didn't even read that part.
Try to rely upon your notes from exam 1, 2, and 3 because you can use those for the final. If you don't have them, you should make them now. Find notes about this. You better darn well make notes about this that you're going to use on the exam. What's empirical rule? Someone help me out. What's empirical rule? It's the 68.
Yeah, for one standard deviation, 68%.
So to get the.
Well, give me the numbers. 68.
It's 68, 95, and 99.
Oh, yeah, it's,
I remember that. So it says that 68% of data will fall within one standard deviation. 95% of data will fall within 2 standard deviations, Nicole. And 99.7% of data will fall within 3 standard deviations. So use that. Maybe you draw the little line, you put in your mean, and you kind of do the little hopping, right? You could do that. But solve this problem. This one, so you have sort of your mean in the middle, and sometimes you can draw a little picture and say, okay, let me subtract the z-score, or sorry, standard deviation. Subtract another one, and then I can go the other direction. 37, add a standard deviation, I get to 44. Add another one, I get to, 41, 44, no, it's right, 51. Add another standard deviation, I get to 58. So, what's the approximate percentage of hamsters weighing between 23 and 51 ounces? Well, that's this one and that one. Those are 2 standard deviations away from the mean. So that is 95%. Using the empirical rule, within which range would you expect to find 68%? So that's within 1 standard deviation. So that is 30 to 44 ounces. And then last, Snowball. Secretly want a hamster named Snowball. No, I really don't. But let's see. He has a weight of 32 ounces. So what's his z-score? So his z-score is, remember your z-score is how far you are from the mean in standard deviations. So first figure out how far you are from the mean. 32 minus 37. And then what is that in standard deviations? Divide by standard deviation. So that's going to be negative 5/7, which is negative 0.714. Good? Okay. Next. Is everybody all good with this mean, median, mode stuff? For the median, don't forget, put it in order. 0, 1, 1, 1, 2, 3, 6. So 1 is median, not 3. Everybody on board?
Yeah.
Okay. What do you feel better about, the GPAs or the weighted mean?
It's not the same thing.
Neither of them.
Neither?
Isn't it the same?
Okay.
thing?
Feel better about the
I feel
GPA?
better about this.
Okay. All right, so do this one, and then when you're done with that one, do the GPA one above it.
Are they on the? Oh, they're on the same page.
Same page.
Okay.
Hey, listen up. Omar's going to explain what he did. Omar, go ahead.
Alright, so you have your score and your weight. So your score is basically going to be your x, and then your weight is just going to be your weight. And so in this case, your weight adds up to 1. And so that's what you're going to be, and that's what you're going to end up dividing by. And then you just find your totals basically by doing 80 times 0.20, so your score times weight. And so that adds up to 76.95. And then you divide that by 1, but it's just 76.95 as your weight.
Good. Makes sense? You always divide by the sum of your frequencies or the sum of your weights. Good. I would like you all, does this make sense for people?
yes.
All right. So really, I wouldn't stare at it. Make sure you understand what's going on. Multiply every score by its weight, divide them, and divide by the sum of the weights. So, or the sum of the frequencies. I have this problem in here, and I can't remember, but I think there's a chance it's in here because it might be on the final, a similar problem. So there's like, I would say there might be like a 25% chance a problem like this would be on the final. I think it's fair to say. So here, you have coins. And then you have how many coins you have of that type. So I have 4 pennies, I have 6 nickels, I have 3 dimes, 7 quarters. Is everybody making sense for people? What's the average value of a coin? So try to work that one through. It's a similar sort of problem. Okay, I feel like people are getting a little lost with this. So what is it saying? It's saying I have 4 pennies. So what is that? I have, you can think of it this way. I've got 0.01, and I've got another 0.01. I've got another 0.01, another penny, I got another penny. And then I have six nickels. 3, 4, 5, 6 nickels. And then I've got 3 dimes. You don't have to write this out if you know how to do this. I'm just writing out for people who are maybe unsure. And I've got 7 quarters. 5, 6, 7. And I want to average these. So what would I do? Well, if you want to average a bunch of numbers, what do? You add them all up. And you divide by how many there are. How many coins do I have all together? Count them all up. Right? So that's how you would average them. Everybody on board? So you can totally do that if you want to. However, again, one of the big points of math is to help us be lazy. So, if I want to add up 4 pennies, well, 4 pennies, how much money do I have if I have 4 pennies? 4 cents. Multiply them. 4 pennies, like Bella did, that's 4 cents. 6 nickels, how much is that? 30 cents. If I have 3 dimes, how much do I have from that? 30 cents. 7 quarters, what do I have? $1.75. Yep. Add those up.
239.
What'd you get?
239.
239?
2.39.
Yep. I have 239. Now, how many coins do I have?
20.
Add those up. How many coins do I have all together?
20.
20. So it's going to be 239 divided by 20. Does that make sense for folks? And ends up being
11.95.
11 what?
11.95.
11.95. Yeah, I'm fine if you give me a few dozen places. I don't care. More is better than 2, so that's fine. If you put 0.12, that's fine. You put 0.120, that's better. 3 stick figs is always good. So since you got this 5 next, I might just put. I would if this was a 4 or a 6 or a 7, I'd probably round it. But since it's a 5, a lot of times I just like to just leave it because it's so close to a half. Yeah, Alex.
Even though the problem is in cents, and it can't be less than 2 digits, you want us to put 3 significant figures.
Yeah.
Yeah, it's in dollars. 0.25.
Yeah,
It's-
but you can't have less than.
Oh, because it's in
11
pennies.
cents.
Yeah, that's still the average value. Like, what's the average number of children a household has? 2.4 kids. Can you ever have 2.4 children? No, but your average can be 2.4 children. If I flip a coin 5 times, how many heads do I expect to get? 2.5 heads is how many you expect to get. But you can never actually have 2.5 heads. So your expected value, your average, your mean, can be a number that you can't actually achieve. Yeah, that's a great question, Alex. Thanks for bringing that up. So your mean is not necessarily, very often your mean is not a possible data value. Destiny, go ahead.
Okay, so first you multiply across, so you multiply the value of the coin times the number you have. Once you get those values, you add them together. That's how I got 2.39. Since we're trying to find the average value of the coin, you divide by the number you have. So you add up the number you have, which is 20, and you should get 0.1195.
Yes, and you can kind of think of it like this. You can kind of think of this as being value times number of coins. And then I guess, so this is really value times number of coins, and you should figure out, if you're kind of looking at the units for this, 2.39 value times number of coins. And the question is, do I want the average value or do I want the average number of coins I have? I want what do you think? Do I want the average value of a coin or the average number of coins I have? I want the average number of coins? I want to know on average how many coins do I have?
No.
Look at the top, an average value.
Average value of a coin. So so if I want the average value, then I should divide by the number of coins. Does that make sense for people?
Yes.
Number of coins. So that these two cancel out. So how many coins are there? There's 20 coins. Right? Okay. So there are 1, 2, 3, 4, 5 more problems that I feel like we really need to cover if you're going to be prepared for the final. This is the first one. This is number 6, I believe. Everybody take a look at number 6. And I want you to spend a minute trying to figure out what kind of problem it is. If you want, pull out your exam 2 and 3 and 1, 2, and 3 notes and see if that will help you at all. Did I talk to you folks about how the exam's going to be grouped where it's like the first exam 1 material and then exam 2 material and then exam 3 material, then exam 4 material?
No.
Oh. Okay. So now, yeah, I'm not going to tell you when it switches from one to the other one, from one to the next. But I'll put all exam 1 first, and then when I'm done with that, I'll put in the exam 2 stuff next, and then when I'm done with that, I'll put in the exam 3 stuff next, and then when I'm done with that, put the exam 4 stuff next. Or you might get the other exam where I start with the 4, and then go to the 3, and then go to the 2, and then go to the 1. So do one way or the other. Okay. So that should help you a little bit. So this one, right? This one will be, somewhere along the lines of, between the well, is this exam 3 material?
No.
No, because that's hypothesis tests and confidence intervals, right?
Yeah.
So then is it exam 1 material?
Yeah.
Maybe, it might be. So it's either 1 or 2. It's either 1 or 2.
I think it's 2.
Some people think it's 2, some people think it's 1.
Wait, I don't know what my card.
Okay, so what kind of problem is this?
Binomial.
Binomial.
Yes.
How do you know it's binomial?
Because it gives us a P and also gives us N.
Right. So there is something happening over and over that, again, that's a yes/no question. Is everyone with me?
Yes.
So it's a yes/no thing. Like, are you, do you have a college degree? Do you have a college degree?
No.
Do you have a college degree? So how many times am I, so I'm asking a yes/no question. How many times am I asking it?
Like 8 times.
8 times. I know how many times I'm going to ask it. So that makes it binomial. A yes/no question, and you're only doing it a certain number of times. You're only going to do it 8 times. So this is binomial. Everyone find the formula for binomial. Find it, find it, find it. Should be in your, like I said, in your exam 2 notes. Like the note card you're going to use, that you use for exam 2, find that. Or if not, make one now. Just be on there. Find it.
Remember?
Yeah, the note card you can use on the exam. The half page of notes you're allowed to use on the exam, your cheat sheet.
Yeah.
Look at that, because that you can use on the exam, right?
Yeah.
Yes. Somehow I'm not speaking clearly. I don't understand why. I was like, oh, you mean blah, blah, blah. Yes. Okay. Someone give me the formula.
NCN.
Someone else besides
NCX
probability of x is equal to NCX
times the probability
times little p,
raised to the x
uh-huh,
times little q or
Little
q
Mhm.
raised to the n minus x.
Good. Okay. So everybody work on these. Oh, remember I love this binomial distribution. Why? Because the mean, variance, and standard deviation is the easiest in the whole world to find. My mean is what? NP, exactly. My variance is NPQ, and my standard deviation is
The square root of n.
square root of NPQ. Good.